do the presentation, and just let me get the recording started and give you control. One moment here. I had the wrong screen open. There you go. And Andy, it is all for you now.
All right, so I think, let me see here. So I've got show my screen. Let me go ahead and kick that off. And so Jason, is that showing up now?
Yep, I can see your screen.
All right. And is the, I'm sorry, is the GoToMeeting, GoToWebinar panel showing, or do I need to minimize that? Okay.
Yeah, that is showing right now. So if you click the little orange arrow, it'll make it collapse. It'll make the blade.
Gotcha. There we go. Perfect. Sorry for the technical difficulties. It's been a little while since I've been in GoToWebinar, and this is actually my inaugural presentation with a virtual chapter of PASS, so it's pretty exciting for me. I've spoken in a few user groups and a few SQL Saturdays, but first time on one of the virtual sessions. As Jason mentioned, my name is Andy Roberts. I'm a data platform architect or data solution architect, depending on the day of the week, what they want to call me, part of the sales team at Microsoft in the Northeast District. And my focus is on both SQL Server, on-premises implementations, as well as in general data solutions in the cloud. And I think this is an interesting topic, with being the data factory, or actually many of the topics that we have. As I'm looking through some of the virtual chapter presentations coming up, in that it's the professional association for SQL Server, but a lot of this is really just data at Microsoft, data with Microsoft. And as you'll see, the Azure Data Factory, while it works with SQL Server and can work in conjunction with different SQL Server solutions, is definitely not a SQL Server product, right? So it's a cloud-based data movement orchestration product. Before I get going too far into this, I don't want to forget to give credit. Much of the content that you see in this deck, and I'll send this deck out to Jason. I don't know, Jason, if you'll post this somewhere, or if people can email you to get the deck. There are a lot of links in the notes in this deck, and so a lot of the content and those links were compiled by one of my colleagues, Buck Woody. And for those that don't know Buck, let me see if I got his mug here. This is Buck Woody. If you ever see him at SQL Pass, say, hey, Eddie, you did a great job presenting your content. Give him credit for anything good, and anything bad you can blame on me. But really, the reason I wanted to show his mug here is he has a blog here called Backyard Data Science. A great, if you're getting into big data solutions, if you're getting into machine learning and trying to understand some of the intricacies, coming from a SQL Server background or a developer background, this is a great starting point. It doesn't jump in assuming you have a stats degree, or assuming you're coming from fresh out of college. He does a great job trying to make that transition from a developer or a database professional into the data science and the big data world. So with that, what are we trying to do here? We're going to talk about Azure Data Factory and kind of where it fits into the landscape of we call it the Cortana Intelligence Suite, and really just the landscape of products that we have put together at Microsoft to solve a large variety of data problems. Understand Azure Data Factory itself. So first we're going to kind of look at the outside, figure out where Azure Data Factory fits, and then we'll look inside of Azure Data Factory. What are the different pieces and parts that you'll see inside of the Data Factory? And then we'll walk through just a sample implementation, pulling some kind of a typical situation of pulling some log files on a daily basis. Maybe doing some transformational work on that in HD Insight, and then pushing the results of that into say a data warehouse in Azure SQL. And then the takeaway we're trying to get here is that this is the solution that's out there today that you can actually put together today to build pipelines, kind of data pipelines to solve solutions, solve problems that you may be running into today. So with that, what is the Cortana Intelligence Suite? The suite itself is a suite of products that allows you to predict outcomes, prescribe actions, and automate decisions. It's geared around predictive analytics and solution predictive analytics. So not necessarily just data exploration or reporting or what have you. It's everything that goes into trying to trying to prescribe actions or automate decisions. So kind of what's the difference between these three things? Predicting an outcome might be I think it's going to rain tomorrow, right? So I'm making a prediction about the umbrella, about the weather. Prescribing an action might be I think it's going to rain tomorrow, so you might want to take an umbrella with you, right? And automating decisions, I think it's going to rain tomorrow, so I'm going to actually put an umbrella out by the front door so you can remember to pick it up on the way out. And as you can see, as I get more intelligent about hey, I can go outside with or without an umbrella. I know I'm going to get wet and be unhappy if I don't have that umbrella. I know I'm trying to be happy, so I can think about the right actions to take. I'm getting more intelligent about the data as I'm acquiring more information, etc. So, pretty kind of simplistic view of what we're talking about here, but you can apply those same principles to larger solutions. So, now tomorrow, if somebody asks you what is Cortana Intelligence Suite, you can say it's that thing that Andy said was about the weather, and you'll be right. But really, the suite it's a stack of products that build on top of each other. Microsoft, we sell it as a suite, but really they're just products that you can use individually. You can use pieces and parts of these in any solution that you're building. And if we walk up from the bottom to the top, everything runs on Microsoft Azure. I know this is a kind of a cloud-focused group here, so I'm won't wax poetic about what is Azure, but it's really it's a place where everything in this solution is going to live or be controlled from. Azure Data Factory, what we're talking about before, is about movement. So it's the orchestration of data movement. And as we'll see, Azure Data Factory itself is sort of what I call a lazy service. It likes to direct, tell people how to move data, tell people what to do with the data, but it doesn't do a lot of the work itself. It's really orchestrating, the movement of data from one store or one service to another. Data catalog is a place to house data. I'm sorry, a place to a library for data, right? So I can inspect various data sources in my organization, both on premises and in the cloud, and store metadata about the various data stores and data repositories that I have access to. Event Hubs is all about data ingestion. So it's in some cases where I guess all up in Azure we're ingesting over 1 trillion events per day. So thinking like IoT type of scenarios, sensors, application telemetry, etc. Sending data in through the Event Hubs. Data Lake is a large data store. So if you think about traditional blob storage that you would have either as a target for data movement through Azure Data Factory or building solutions for use with HDInsight or Hadoop. If you use traditional blob storage, there's size limits, there's scale limits, there's complications that arise as you start to break through the hundreds of terabytes level. Azure Data Lake has none of those size type of restrictions. We can store files up to the petabyte range, etc. Azure SQL DB, Data Warehouse, Document DB, These are SQL and NoSQL stores, right? So Azure SQL DB is, as we all know, it's essentially the SQL Server database as a service, for lack of a better term. Data warehouse being the MPP, or the massively parallel processing version of that. So I can enlist many SQL servers together to solve a larger problem. Document DB being a JSON store. Machine learning is really the place where we can create predictive analytics solution and publish them. So I can actually operationalize a predictive solution through a web service. HD Insight is kind of again, big data compute. So this is the analytics piece of the big data platform. We also have Azure Data Lake Analytics is kind of a new offering here that's on the slide. Stream Analytics is complex event processing or standing queries against streaming data. So if I have those millions or billions of events coming in through my system, I might not want to write every single one of them out to my Azure SQL database or to a log file. I might want to look at smoothing that data, rolling averages, things of that nature. And then finally, Power BI, the visualization layer. So dashboards, reports, and also recently the ability to embed reports, these dashboards into applications and websites that you're creating yourself. And then Cortana, which we kind of know through, or many of us might know through, the button on our phone that we can talk to, but it really represents the kind of the human interaction piece of these solutions. So, like for example, I can enable a data set for Cortana integration, and then in my Windows 10 client, I can say, hey, what's the market share for my product in Australia this year, and how's that grown over last year? I can write that in English language, and it will navigate through the data sets I have stored in my profile and say, here's a visualization that represents that question you were asking. So those are, again, just the various components that we're trying to integrate together with Azure Data Factory. So Azure Data Factory is really kind of a hub that moves data through those various components that we use to put together a predictive solution and build that into an application or a solution that we're developing. So we can think about operationalizing this in various tiers, and really, Azure Data Factory fits in this information management tier, but really reaches out. We kind of draw arrows only going from one tier to the next, but Data Factory reaches all the way, into your operational systems that might be running on premises, and all the way out into Power BI or machine learning, for example.
Okay, and Andy, we got a question here. Is any of this stack based upon the Microsoft Solver Foundation family of linear and integer solvers for minimizing and maximizing an objective function?
I'm not sure if I'm not familiar with with Silver in that context.
Okay.
As you're putting these solutions together, you'll come across something called the Cortana analytics process. This is something that's I would say based on a process that we call CRISP-DM, which was developed outside of Microsoft. But it's the idea that you're putting a process together to solve data science type problems. And really what I'm getting at here is there's nothing new in the data science process, or even in there's some new stuff in machine learning and whatnot, but you're kind of building on the foundation and trying to streamline some of the operations that we've been operating on, acting on for quite a while. So with that, what is the Azure Data Factory? The Azure Data Factory is a service that allows you to create, orchestrate, and manage data movement and enrichment through the cloud. And again, what I want to get across here is that it's you're orchestrating and managing the data movement and enrichment. The data factory itself is not performing the ETL operations themselves, or really the transformation operations themselves. It's going to be reaching out to other services and telling them what to do. So one of the questions that comes up a lot when I talk to my customers is what is the difference between Azure Data Factory and SSIS, right? Because SSIS also gives you the ability to reach into a lot of data sources, pull data out, run through transformations, and put that data back in somewhere else. In those cases, all of that data is running through the SSIS process, right? It's coming into the whatever machine SSIS is running on, and SSIS is doing something with it, right? It's changing data types, it's pivoting or unpivoting data, it's doing fuzzy lookups, and it's SSIS that's doing that work and then running it out somewhere. Whereas Azure Data Factory is built more in that the new kind of ELT mindset, where I'll be extracting data or reading data from a source file or a source system, putting that data pretty much unchanged into a destination system. Now, there is some transformation that may need to occur in that process just for data type alignment, or I might decide to not copy 10 of the 15 columns that I read out of a flat file, right? So I can do some column projection and things like that. But I'm not going to be doing the matching and the joining and the fuzzy lookups as in ADF itself. So we'll see a couple of examples of that in the demo. When I think of ADF, and if there's one picture to kind of have in your mind, or one slide to remember, I would say it's this one, and really understanding these four items and how they relate to each other goes a long way when you start navigating the blades in the Azure portal for Azure Data Factory. If we start down at the bottom here, because starting at the bottom is always the thing that makes the most sense to me. The linked service, right? So linked services are services that Azure Data Factory will reach out to either read data from, write data to, or perform some action. Okay, so these are things like Azure Blob Storage, or Azure Data Warehouse, a Hadoop cluster, or on-premises even, maybe a SQL Server on-premises. I can actually reach out through the enterprise gateway, pull data from an on-premises store. Now, we're moving data, and somewhere we need to define that data, so we define that in the data set. So these are, for example, the files that I would create or read from, or the tables I would create or read from. Now, activities will run on a linked service, and they will consume and or produce data sets. So I might have an activity called a copy activity, and a copy activity has a source and a sink. The source being the file I'm reading from, and the sink being the data set I'm reading from, and the sink being the data set I'm writing to. So I would say I'm going to read, say, from a flat file that's stored in the linked service that's a blob storage, and I'm going to write to a SQL table that's stored in a Azure SQL database that I've defined, right? So pretty simple. When you think about it and we really break down to those terms. Other types of activities would be like machine learning batch scoring, right? So it could actually create and publish a, let's say, a customer segmentation experiment, and I expose a web service, right? So when I publish that experiment, I publish a web service that I'm going to pass in a bunch of parameters about a customer, and it's going to return, what bucket that customer resides in, right? Is this, a male greater than 40 years old living in the Northeast, or is this a female between 20 and 25 living in the Southwest, right? So like demographic type of profiles, or maybe is this a frequent buyer, or someone that has not purchased from us, or has declined in purchasing history in the last 6 months. So in that case, I would read a data set, and then the activity would enrich that data set, right? So I'm going to pass that data set to a machine learning web service. It's going to append a column or a couple of columns, so it's going to a bucket and probably a probability that they exist in that bucket. And then I would take that output and write that to a data warehouse or another file, for example. And so when I just spoke there, I talked about chaining a couple of activities together, right? So I've got maybe a batch scoring call followed by a copy call. And as I start chaining these activities together, this is what we call a pipeline. So a pipeline is a set of activities that are scheduled and managed together. So those are really the foundational components of Azure Data Factory. We'll see how they fit together in just a moment. There's one other key piece of kind of key term to get your head around when you're looking at the Data Factory. And I don't have a good slide on that, but we'll talk about it when we go through the files. Is the idea of data slices and windows. And for anyone that's been doing data movement, populating data into a data warehouse, for example, this idea should resonate pretty readily. But like I need to read data from a data warehouse or from an operational system every hour or every 15 minutes or every day or month. And those are what we call slices or windows of the data. And when I define my pipeline and my data sets, I'm going to define how frequently are you allowed to pull from that data set, and how frequently I should execute that pipeline. And again, we'll see that in the demo. So this is a typical flow. So I'll probably have some event ingestion or some data ingestion, copying data from various source systems and landing it in its raw form, whether it be in blob storage or a data lake or copying it directly into a database. There'll be probably some preparation steps, some cleansing steps on that data, maybe doing some basic enrichment, geocoding addresses or scrubbing names, etc. And then I'll have some transformational steps where I, maybe I'm maintaining slowly changing dimensions in a data warehouse, or I'm deciding whether I'm going to actually, append new rows back table or update history, depending on the type of activities I'm tracking. And then finally, I'll publish that data out, to whatever stores I'm using for consumption. And with that, I'm actually going to go ahead and jump right over going to jump past a couple of these. So I think we've talked about a lot of these points, right? So if I think about the process in general, you have to know what you want to do. That's really what that first point is. You're going to create a data factory, and we're mostly going to be using the portal today. I'll also show you where this sits inside of Visual Studio. There are PowerShell commandlets in the Azure PowerShell commandlets to control Azure Data Factory as well. The first thing that we need to do is create the linked services. Say what are the services that we'll be using as part of the process that's going to be doing the work for us. We'll define the data sets, the inputs and outputs, and then create a pipeline that's going to chain activities together to actually perform the transformations. Once it's all set up, we'll see how we can monitor and manage the pipelines themselves. Let me just I'm going to skip past just in the interest of time here. Couple of places that we can create and manage data factories. So the first is the portal, and this is where we'll spend most of our time today. The next is PowerShell, and again in the notes there's some links to the commandlets that you'll be running inside of PowerShell. And I think actually the next slide has some references. So for example, creating your resource group, adding in the pipeline, etc. And then the third is Visual Studio itself. I can either create a new data factory project or I can connect into my existing subscription. I can export a data factory into a new project, much like you would do with Azure SQL database and creating a new database project from the database. So I can start by creating a new project, or I can look at an existing database and create a project from that. So actually I'm going to step through these just because we talked some detail before we get into the demo. There are a lot of linked services that are available. And what this table defines is for each type of data source, where do I know how to move it to, right? So if I have a Azure blob of essentially a file in the cloud, I can copy that to another blob. I can copy that into an Azure storage table, a SQL database, data warehouse. I can move that on premises to SQL Server. I can move that into document DB, onto the file system, to data lake store, etc. So not every combination is available. We can move from Oracle, MySQL, DB2, Teradata, etc. into SQL Server. I don't see a lot of options on us moving stuff from SQL Server into Oracle. I'm not quite sure why, but that's just the way it's set up today. Looking at different activities, these are really the different types of transformations, and the one basic is copy. That's the basic data movement. I can also execute Hive and Pig jobs, map reduce jobs. We talked about machine learning. I can execute a store procedure inside of SQL. I can even write my own .NET activities that would run. That's the one time it would run inside the Azure Data Factory process, or Azure Data Factory would be doing the work there. Connecting to on-premises data stores, we connect through a gateway. So this is actually an old slide. It's now I believe it's now the enterprise gateway that we connect through. So it's a whole separate topic on getting that set up and configured, but it allows me to reach outside of Azure onto your premises and reach into whether it's file systems or relational databases, etc. Creating the data sets, pretty straightforward. Like we'll see, all of these items are defined with JSON documents, much like setting up resources in a resource group today. You've got a name of the data set, you've got some structure that you can define, necessarily have to define. The type of the data set, is it a file or a SQL table? And then external ends up being a pretty important flag to set for essentially the start of the pipeline, right? So if I've got a file that's generated by Azure Data Factory, that's set to false. If it's a file that is kind of the kicking off point of the data movement process, I set external to true, so I'm not waiting for it to be created by another component. And then we'll talk about availability and policy as we get into the demo. And then finally, we create the pipeline. Like I said, it's a logical grouping of activities that we've defined. And important note is a start and an end time. So we can define when a given pipeline is active. We might actually want to keep an old version of a pipeline available, even though we've got the next version of, like let's say I'm performing a new set of actions on those files or on that source data. I might want to keep the old ones active so I can regenerate data as it was, say, last month when that pipeline was active, right? So I can reprocess a slice of data as it was processed in, say, version 1 instead of the current version 2 of the product. And then finally, monitoring the solution, we'll talk about in the demo portion. So with that, before I skip over, Jason, any questions online? Or do you have any questions?
Yeah, there's one other question that came through. From a small business perspective, if somebody already has an Azure account with some infrastructure as a service, VMs, Azure SQL databases, and they're seeing some uses for ADF, how do they estimate the additional costs for using ADF?
That's a good question. I don't have the costs off the top of my head. There is a cost for each time an activity is run, and let me actually see if we have time towards the end. I can pull up the pricing sheet. If not, I'll make sure I include that as part of the slides when I send those over to you, Jason. So whoever asked that can reach out to you for that. But it does exist in the pricing calculator, and really it's what it comes down to is the more complex the pipeline is, it ends up being nominally more expensive. Where it does get a little tricky in the estimation is I think there's a difference between an activity that is run once or an activity that is run multiple times. And then I think the other breakpoint is if a pipeline is scheduled on a daily basis or more frequent than a daily basis. So if I'm running it more frequently, I end up with a higher rate than if I'm running on a once per day basis. But those are the two main variables. I just can't remember the exact price points. Does that make sense?
Yep, that makes sense.
Let's jump over to so what I have is I've got a data factory that I've already set up with some sample pipelines. But just to walk through, I know that I would assume that most of the call are familiar with Azure, in general. So I've logged into my account. If I say new, we can see data factories in my recent list here. There's not a lot of options when I set up a new data factory. It's really, where am I located, and what resource group should I belong to? And where I'm located, again, it doesn't doesn't make a ton of difference, right? So if I set up my Azure Data Factory in the East Coast, in the East, say East Data Center, I can still move data between the West Data Center and South Central U.S. or Southeast Asia data centers. I'm not really restricted to operate on data that is where my data factory lives. It's really more for a management control perspective. Because again, remember the data factory itself is really just orchestrating. It's not actually performing the actions. So let me jump into the data center, the data factory that I have created. And in this data factory, you can see I've got 7 data sets that are defined. I've got some pipelines and linked services. I created this from a sample just so everyone can kind of look at how this gets put together. You can work out the same thing that I was showing you today. So if you go to sample pipelines and you say customer profiling, what it's going to ask you for is a storage account where it's going to put some sample data, and Azure SQL DB, where then it's going to just create one table in that database and copy some data into it, and then a username for that database. So pretty simple creation. It takes about 5 minutes. This solution is really around, say, like gaming events, and saying, hey, if I had these gaming events, and part of that is an IP address from the telemetry information, so I can enrich that with maybe a location, and then I've got some user information. I can add some customer segmentation information in there, and then write that out to a SQL Server database for marketing analysis. So when I look at my data factory in the Azure portal here, the first thing you'll want to look at if you have an existing data warehouse or data factory is the diagram. So the diagram is going to just give a kind of a graphical depiction of your data flow. So as I mentioned, I've got raw files that are dropped into blob storage. The first thing I'm going to do is I'm going to take that raw file and I'm going to move it into a set of file partitions for use by Hive. So when I look at executing a Hive job, I'm assuming I can set Hive up to respect partition boundaries. And so that's the first thing that I'll do there. I will then execute a pig script that will join in my my IP address to geolocation table, which is just stored in another blob file at this point. And finally, I will add in some marketing information and then store out to another partition file, and eventually land that inside of a SQL Server database. When I first looked at this, I was like, wow, this is a pretty heavy-handed approach to execute 2 joins and write files into SQL Server. This is something that I would, probably in a traditional data warehouse, I would do with like, one bulk insert and then a store procedure that does those joins. It's probably going to execute a little bit faster and not really all that complicated. But really, this demo example, a sample is meant to illustrate the different ways of solving certain types of problems. I mean, if I was looking at real, say telemetry from Xbox, or if I was looking at larger data volumes or more disparate data sources. Some of those options might not be as readily available to me in a traditional landscape. So how would I list certain types of features of Azure to solve that problem? So let me this is kind of the view of what everything looks like when it's put together. Let me jump over to the other area that you'll spend a lot of time as you're putting together a Data Factory solution. So if I look at the author and deploy blade, you can see I've got the components that I talked about earlier. I've got link services, data sets and pipelines, and I've got my data gateways, which is how I define reaching back into on-premises stores. I didn't really think about it as a separate component in my diagram there, but another thing I define here as part of the Data Factory. If I look at the link services that I created, you can see I've got an Azure SQL Server, Azure SQL Link Service. This is really what I define here as a connection string, right? So this is just a placeholder for how do I connect to the SQL database or this SQL Server database. I've got HD Insight linked service, and so HD Insight is the managed Hadoop environment inside of Azure. One of the really cool service types is what we call HD Insight on demand. So you can see where it says type HD Insight on demand. What that's going to tell Azure Data Factory to do is it says, when I try and connect to this HD Insight on demand linked service, create a new Hadoop cluster and then perform any actions that are needed with that Hadoop cluster. So any actions that are using that HD Insight on demand linked service, and then if that link service goes idle for 5 minutes, shut it down, right? Because I might create a cluster with 2 head nodes, and I might have like say 10 data nodes, right? That's a lot of cores that I've got running, consuming my counting against my Azure Azure quota, Azure usage. So I can say, spin this up, process data as fast as I can, and then when I'm done processing, shut it down. So that's all managed by Azure Data Factory, not something I have to think about as an end user or as a developer. And then my storage link services, these actually point to the same blob storage account, but again, if you look at the blob storage account, if you look at the connection string on it, you'll see I've got my account name, and then my account key, which is start out. Because we don't, it's just protecting the sensitive information there. Once I've defined my link services, I can define my data sets. I'm not going to go into each one of these, but just as a couple of examples, this is what a table might look like. So I've got, I'm going to skip past the structure here, and you can see that the type is Azure Blob. The linked service where this data set is defined is the customer profiling storage link service, that storage account link service that I showed above. I define the folder where this storage, where this file exists, and you can see this folder path. I've got a pretty long path here. You see, year no equals year, month no equals month, day no equals day. That's how I'm defining the partitioning structure for this file. So when I look at this file, the file itself, to when I look at it in Hive, will be in enriched game events. But because I've defined this partition structure, it knows to look for all of the files in the various folders in that structure to comprise one large file. So if I'm looking specifically at the events in May of 2014, I don't, it's going to automatically eliminate scanning 2013 or 2015, right? It can just eliminate the files that make up those partitions. So I define how I'm going to define that partition. So I've got year. As I mentioned, we think of data, these data sets as made up of a bunch of slices, right? I'm pulling, in this case, in this example, every day. And so my slice start is going to be, the year of that, or the slice, the partition will be based on that date that makes up the slice start. So the year, the month, and the day. So we'll show the one. So all of these are various blob files, except for this one, which is a SQL table. So this is the one SQL table we're writing. You can see the type is Azure SQL table. My link service name is Azure SQL Server link service. And I'm defining that same structure here. And then finally, if I look at just a couple of the pipelines, you can see I've got, so the first one here, which is partitioning the game logs file itself. And what this is saying is it's going to use a Hive job on HD Insight. So I'm going to tell it to use, well, I can tell the script path and script link service is saying, where is the Hive script that I'm going to execute. I could actually inline the script as well, but in this case, I'm going to store it out as a separate file. Define the partitioning structure of the files I'm looking at, and I will, at some point, say that I'm using that HD Insight on-demand service. And then after the link service name, which is down below the screen there, customer profiling HD Insight link service. So that's that on-demand service I created. Now I'm saying that I want this pipeline to run from run on data that was created between 2014 May 1st through 2014 May 5th. That's what that start and end represent. That's different. The data slices are a little different than the execution time of the pipelines themselves. So I can define data at a slice more granular than I'm executing pipelines, and it's going to pull together multiple files, for example, or multiple slices, but it'll maintain those. It'll work on each of those slices as one set of data, essentially. And this might crystallize a little bit as I go back to the diagram and we dig back in there. So I'm just going to jump right to the end of this file here, and I'll look at the data coming into my my SQL Server database. And now, at this point, I've deployed all of my pipelines, they've already executed. So I'm looking at the execution status of different activity executions in the data factory itself. So you can see that my last update time on all these pipelines was today, and then you see the slice start and end time of 5.1 to 5.2, 5.2 to 5.3, 5.3 to 5.4, 5.4 to 5.5, right? So those are the 4 days defined that I've defined as the start and end dates of the pipelines themselves. And because I made the data sources available at a daily interval, that's why it's defined the slices up as a daily slice. If I jump into 5.1 to 5.2, actually I'm going to go ahead and I'll rerun this slice. This might take a little while to kick off, so if it doesn't start right away, I won't worry about it. But you can see in this case it took 2 minutes to run that execution. Now, it took 2 minutes to execute the pipeline. It didn't take 2 minutes to load the data itself. It took about 7 seconds to actually do the data copy. But part of what Data Factory is doing is it's validating the sources that I'm pulling from. It's scheduling the different activities on the environments where the pipelines will execute, etc. So again, if I'm thinking about this in the context of a pretty simplistic example like this, like wow, it's a little heavy-handed to distribute this work across so many different environments. But when you're thinking about some of the more larger, complex systems, it ends up making a lot more sense. The other thing just to kind of keep in mind is there's a lot that's going on here. That's in this example, that's code that I would have to think about writing myself, right? As you can see in this diagram, in order to execute this customer profiling, which is analyze, marketing events, marketing campaign, to execute that pipeline, I need to make sure that I've got 2 files that are ready, and that those data slices, not only is there data there, but it's the right slice of data, so understand how to walk back across this chain to make sure that it executes the appropriate activities to pull data as far back as it needs to reach before it has valid data. So if I had run nothing, if I had no data in the system, and I just said execute that one slice, it would reach all the way back into that raw gaming events file and first partition it, and then enrich it, and then run the analyze marketing events. But in this case, I already had data in the enriched game event, so it knows just to reach back to that one file. That's and then also if these aren't scheduled on a hey, this usually takes 5 minutes, so I'm going to schedule this to be 15 minutes later. And if this happens to take 20 minutes, then I'll miss my window. All of that logic is kind of gone away. It's saying, when this event is finished, trigger this next event. It understands those relationships at a little deeper level than most of the ETL code I've written in the past, at least. So I mean, that's kind of in a nutshell what you're seeing in the diagram itself, or in the data factory itself. 2 other quick ones, and I know I'm kind of running up on end of time here, Jason, I think. Couple of quick notes. There is another kind of a starter pack, I would say, for creating very basic pipelines, right? So this copy data, copy data pipeline, pipeline generation tool will allow you to just say, hey, you know what? All I need to do is copy data from, say a blob storage to SQL Server, or from SQL Server to my Hadoop cluster. And it's going to it'll generate the data sets, it'll generate the link services, it'll generate the right activities and pipelines to get you out the door for a basic solution. Okay, and it's a wizard different approach, so you don't have to worry about entering data into the JSON files. Because I'll tell you, someone that hasn't done a lot of memorization of the properties and the attributes and everything else, the JSON files can be a little bit daunting the first time you get into them if you're not used to that world. But so the copy data tool helps you get past that to start with. The other thing that's in preview, I think it was recently released, maybe a month or two ago, is the monitor and management tool. And I should have had this preloaded before the session, but what this allows you to do is look at your Data Factory pipelines that are currently executing, and without having to click through each one of those data sets and slices, do things like what are the activities that are currently executing right now. I can also backtrack errors. I can see what tables are in a waiting state. So if something is waiting for another event to finish, I can start navigating some of those relationships. Then the last item in the demo that I just wanted to show was the Visual Studio integration. So in the Azure, there's an Azure Data Factory tools download. I believe it's still a second download to integrate Azure Data Factory into Visual Studio. But when you install that, it will show up as part of the Server Explorer under Azure Services. I can open existing assets inside of my existing data factories, or I can right-click and say, export this data factory to a project. Once I've exported to a project, it looks, it's a very similar concept as a SQL Server database project, for example. So I can look at the data sets I've created, the pipelines I've created. When I look at the pipelines, it will give me a graphical representation of that individual pipeline. So you can see I've got a data set. I've got a data set. I've got an activity called join data that generates another data set, which I then copy to a table inside of SQL Server. So that's what those steps indicate. And I think that is about what I had. And Jason, any other questions or anything that I didn't cover that you think I should cover real quick?
Nope, no new questions, and I think you've got it covered.
All right, thank you very much for your time.
Yes, thank you everyone, and see you in the next webcast.